Alright everybody, welcome to the learning target number 123 part 2 of yesterday's video. So I need you to go ahead and flip to page number 5. Okay, so get there, and I put a star here because this thing, I'm pretty sure this is where we left off. So we're just going to we'll skip around, we'll do some, we'll skip some, just depends on where we're at, but just kind of stay with me. If you need to go back and view any of the stuff from last night's video as far as the number lines go or anything with greater than or less than, you can always go back and watch the old video and kind of quiz yourself a little bit. Remember, you can always pause, try it, and then play to see if you're getting it correct. Okay, so here we go. This one right here, fill in the missing fractions and mixed numbers on the number line. Now, first of all, we got to understand what a fraction is. I think you all know that a fraction is showing part of a whole. Okay, and this right here is showing 2/3, so you have 2/3 of a pizza, so you have 2 out of 3 slices of that pizza. Okay, a mixed number is a number here, so I'll kind of draw a little arrow here to show you that's what a regular fraction looks like, as you guys are well aware. And then a mixed number, on the other hand, is going to be one that's like 2 3/4. So that means that you have 2 whole pizzas and 3/4 of a third pizza. So you got your 1 pizza, your 2 pizzas, those are whole, you have the whole entire thing. And then if you have another pizza that's like this, and you're just missing the 1 slice. Okay, so that's what mixed numbers. Mixed numbers are always going to be greater than 1. Greater than 1. Okay? So, if we're being asked to fill in this number line right here, you can see that it's broken into 3 sections. So I got this section from right here to right here. I'll do this in different colors so you can kind of see it. And if you have different colors, colored pencils or highlighters, you can do this if you want. You don't have to. But the point is to show that it's broken into 3 pieces. So because it's broken into 3 pieces, it's like having a pizza that looks like this with 1, 2, 3 slices. Okay, so here at 0, I would have 0/3, right? Here I would have 1/3. Here I would have 2/3, and then here obviously would be 3/3. Okay, if I have 3 out of 3 slices, isn't that the exact same thing as having 1 whole pizza? Hopefully you're all saying yes. And it continues being broken into 3 sections here. So only difference now, we have that 1 whole pizza. So that means this one's going to be 1 1/3. This one would be 1 2/3. Okay, and then obviously, just so you guys know, 1 3/3, if I had that mixed number, 1 3/3, that's saying I have 2. Because I have 1 whole pizza, I have 3/3 of a pizza, so that means another whole pizza. That's why that is equal to 2. Okay? Doing inequalities, remember this right here is a less than because it looks like a squished down L. This is a greater than symbol. Okay? So here we have 2/3 and 1. Well, ask yourself, what's more pizza, having 2/3 of a pizza or having a whole pizza like that? Hopefully you're all saying a whole pizza. So that would read 2/3 is less than 1. 2/3 is less than 1. Okay? Here we go. Here we got 2 1/3. So we got here, this would be like having 2 entire pizzas. 1 1/3 would be I have 1 entire pizza, and then like this. It's really small, sorry. And then having 1 out of 3 slices there. So obviously it's more pizza having 2 whole pizzas rather than just 1 1/3 of it. So that would be greater than. Okay? Okay, draw a horizontal number line here. We're going to, well, here we'll do this one, I guess. We'll go ahead and do this one. It's pretty easy. Okay. All right. It says it wants to do mixed numbers greater than 10 but less than 11. So like we talked about on last night's video, are we going to start this, don't write this, at 10 and go to 11? Hopefully you're all saying no, because we only want our number line to represent numbers greater than 10 but less than 11. So we are not going to put those 2 numbers on our number line. Okay? So if we got an interval, which is the distance between each point, is 1/4, then my first number here is going to be 10 1/4. Then I'm going to go to 10 2/4, which hopefully you're all saying should be 10 1/2. And then I'm going to go to 10 3/4. I know that's kind of squished in there, sorry. But it's going up by fourths. And then obviously, like I said up above, if I had 10 and 4/4, that's equal to 11. And we only wanted our number line to represent numbers less than 11. Okay, so we wouldn't go all the way there. So you'd only have those three numbers on there. Okay. Here, we're just going to do this one really quickly here. Mixed numbers from 3 to 4. Now, because we're going from 3 to 4, we're going to start at 3 and we're going to go to 4. Okay, if it says between 3 and 4, we would not include 3 and 4. Okay, it's all about the wording. It's very much reading. So we're going to start at 3 and go to 4, and we got a distance of 1/10 in between. So that's going to be 3 and 1/10, 3 and 2/10, which you could simplify, and so on. I don't think we need to finish it. I think you guys know what I'm getting at here. It would go all the way up to 3 and 9/10, going up 1/10 each time. Okay. All right, here we go. We'll do this one right here. Actually, let's do this one as a vertical. Even though it says horizontal up there, we're going to do a vertical in practice. So now we're talking about decimals greater than 8, but less than 12. So since we want to be greater than 8, we do not want to include 8 on our number line. Okay? Nor do we want to put 12 on our number line because it just wants everything less than that. So we have to figure out 8 would be down here somewhere. So if we were going up by 8/10 or 0.8, then our first number would be 8.8. Okay? Then we would go up by 8/10. We're going to be at 9.6. Okay, then we're going to go up again. We're going to go to 10.4. Then we're going to go to 11.2. And then if we went up 8 more tenths, it would take us to 12. And we don't want to put 12 on here. Okay? Now, real quick, I'm going to show you this real fast because this is kind of important. If you did put 8 and 12 on like this, if you put 8 and 12 on your number line, which some people can do it this way, and we did 8.8, 9.6, 10.4, and 11.8. If you did it that way, if you just left it just like that, it's going to be wrong. Okay? Because I only want decimals greater than 8 and less than 12, and 8's not greater than 8, and 12's not less than 12. But what you could do, if you wanted to actually do it a certain way, if you wanted to put dots right here on everything you're talking about, that's fine too. So everything that you actually are saying is greater than 8 but less than 12 is dotted. You could do it that way, like you're putting it as a point. I would accept that as well. But I would say probably just avoid this method and just go with the way I'm teaching you. Okay? All right, let's go to the next page. Okay. Here's a vertical number line. We're just going from 0 to 1. See, this is how they did it. See how it says, well, actually, you're just putting the intervals in there, so you're going up by 1/5. The biggest thing, once again, I see students do, this is wrong, so do not write this, is I see this. Like that. And getting bigger as you're going down. Okay? Remember, think of a thermometer. A thermometer is bigger as you go up, or hotter. The temperatures go up as you go up. So vertical number lines can get kind of tricky. Okay? 1/5 is the smallest number up there, right? And then 2/5. Think about having pizza. I have 1 out of 5 slices. I have 2 out of 5 slices. I have 3 out of 5 slices, 4 out of 5. And then, of course, one whole pizza would be 5 out of 5. And 0 would be 0 out of 5 if you want to make them all into fractions. Okay? I want you to pause this, and I'd like you to try this, please. Okay? You're going to represent those decimals. You're going to go up by 2/10. So we're going to represent the decimals 2.0, so we're going to start at 2.0. And we're going to take this thing to up to 4.0. Okay? Because, again, it includes those two. So there's no confusion on is it between those two or is it starting there. It actually includes that in the decimals. So we're going to go up by 2/10. So we're going to go 2.2, 2.4, 2.6, 2.8, 3.0, 3.2, 3.4, 3.6, and 3.8. Kind of got smashed in there, but you get the point. So that should have been relatively easy, I believe, for you guys. Go to the next page. Okay, now, when you're comparing fractions, this gets kind of hard, because when you think about the fraction 2/3 and 5/6, if I was trying to break down which one was more pizza, okay, it's really, really difficult to do this because, well, here, I'll just show you. There we go. So I got 1, 2, 3, 4, and 5. Here I got just 2. Okay, if I asked you which one has more pizza, some of you might say, you might just be able to look at something like this and be able to tell, which is cool. That's cool that you can do that, but that's not always going to work to your, you're not going to always be able to just draw a picture and make it look like it, okay? I mean, if this was 6/7 of pizza, how are you going to cut a pizza into 7 equal slices? Okay, it's too difficult. So we're not gonna rely on that method. So there's 2 ways to do this. Here's the first thing I want you all to write at the top of your paper. Write this, and this is going to be something you're going to hear me say the entire school year. Matter of fact, I think I might have already said it. All fractions are division problems. Okay, all fractions are division problems. Okay, so if I have the fraction 2/3, I can just do 2 divided by 3. It's always top number divided by bottom. Numerator divided by denominator. Okay, so it's 2 divided by 3. This is going to be 5 divided by 6. Now, I don't expect you guys to come over and do 2 divided by 3 and do long division. That's not what I'm expecting you to do. This is going to be the part you're going to be able to use calculators on. So you can use a calculator here. Okay, because as we went over on the review sheet, you can actually, you know how to compare decimal. Well, hang on a second. You know how to compare decimals. So if I do 2 divided by 3, you can see that gives me 0.6 repeating forever. 0.6 repeating. Okay. When I pull up my calculator and do 5 divided by 6, that's going to give me 0.83. Okay. Repeating. So you knew that when we did this, we actually stacked these things up, and that just means repeating, so that goes on forever and ever. You could put as many as you want. You don't need all those. You'll see why in a minute. Okay, and then 8, and then since that repeating bar is just over the 3, it's just like that. And again, you don't have to put all these on there. All right? Remember, when you're comparing decimals, we always work from left to right. From left to right. So we start here in the dimes. Remember I called those the dimes or the tenths. Did we learn which one's bigger just based on the tenths? Hopefully you're all saying yes. The 8's larger, therefore this is larger, therefore 5/6 is larger. And that's the way we're going to do it here at first. Now we're also going to learn a different way. And this is really the better way, and the way I really want you guys to really practice. Okay? If I told you that I had 2 pizzas, let me pull them up here. Give you 2 pizzas, and I said, let's say they're the same size, because they're supposed to be. I cut these into 8 slices. Oh boy, bad. Let's say they're all equal sizes and all that. Okay. Now both pizzas have 8 slices. If I told you I had 1 slice there and I had 3 slices there, which one's larger? Obviously that one, right? It's trying to eat the larger one. Okay, that's easy, and the reason it's easy is because both of these have common denominators, right? Common denominators. Very, 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 very important to know and understand. You guys know that when you add fractions, you'll remember from last year, you have to have common denominators and do whatever you did at the bottom to the top. Okay? Well, this is the same way. If you want to really be effective in comparing your fractions, you're going to find a common denominator. And that common denominator is actually called your least common denominator. You write that, please. We'll talk about that later on in this chapter. But what I always like to do is I just like to look at it and say, okay, what denominator would be a good common one to use? And there's a couple options. You could if you're really good with your math facts, you could recognize, wait a minute, I know that if I multiply 3 by 2, I could get 6. Okay? And then we've now taken our pizza and we got the same amount of slices. Okay? But the key is, if you take that pizza and you took it from being a total of 3 pieces to 6 pieces, then whatever you did right here, you got to do up here also. So what is 2 times 2? 4. So here I have 5/6 of pizza. Here I have 4/6. Obviously this is larger, which is what we set up here, right? This is the method we all need to learn. Finding a common denominator. Now, let's do another one. Same problem, but practicing here. Let's say you didn't recognize that you could make 3 become 6. You know what common denominator they do have? Well, you know that both of these, if you just multiply the two denominators together, 3 times 6, you get 18. So doesn't that mean that 3 can become 18 and 6 can also become 18? Absolutely. What I just did there is called write this, quick common denominator, or the QCD, denominator. Okay? The quick common denominator. That's just where you quickly multiply the two denominators together, get a common one, and then there you go. Now remember, whatever you do to the bottom, you must do to the top. So if I multiplied 3 by 6 to get 18, then I've got to do that up here. 2 times 6 and get 12. And over here, I did 6 times 3 to get 18. I've got to do 5 times 3 to get 15. Now I have 12 18ths and I have 15 18ths. Still the same answer. It doesn't matter how you do it. Okay? I could also use a common denominator of 12. 6 can become 12. 3 can become 12. So I could use that as well. Okay? On a number line, that's all they're showing you here. That you could put them on a number line also. But that kind of involves this process of finding a common denominator and then putting them on the number line that way, and whichever one's further to the right, that's going to be your greater one. Okay? Okay, here, this is pretty basic. You could use a number line here. We have 1.3 and 1.15. Okay, remember we can always add a 0 there. This is like having $1.30 and $1.15. Obviously you know which one's bigger, but let's just start on the left and work our way right. Did we learn anything from the ones place? No. Did we learn anything from the dimes? Absolutely. 3 is greater than 1, therefore 1.3 is larger than 1.15. Okay, we can fill in the missing values here. It's just going up by 1/100th now. So we have 0.01, so that's going to be 0.02, 0.03. It's just going up by 1 in the hundredths place value. 0.06, 0.09, and then here we go to 1.0, or just 1. Okay, we're going to skip this for now. If you want some extra practice, you can do this. It's practicing doing vertical number lines, and if you want to do it and I can check it for you tomorrow, that's fine. But that, I mean, we've done enough of those. I think we're good with that. Okay. Okay, here we go. We'll do these real fast. So I'm now on page number 9, if I lost you. Okay, here I have 3 9/10 and 3 3/10. Now, I've got common denominators, so that actually makes it easier on us. We know that we have the common denominator, so you just ask yourself, what's more pizza? I know that right here, I have 3 whole pizzas on both ones. So both mixed numbers, I have 3 pizzas. So it's all about how many slices of that 4th pizza is how I'm going to be able to tell. And here I have 9/10. I almost have a whole pizza right there. Here I only got 3 slices left. So we know that's going to be greater than. It's going to try to eat the higher amount of pizza. Here, again, come off to the side. Try to do it the way you know how to do it. Like that. Start on the left, work your way right. Did we learn anything in the ones? No. Did we learn anything in the tenths? I'm sorry. Yes, we did. We learned that 7's larger than 1. It doesn't even matter what's in the hundredths at this point. I know that 2 and 71 hundredths is larger than 2 and 17 hundredths. Okay? Same goes for this one here. Here I got 14 and 4 tenths, and I have 13 and 38 hundredths. I'll add a 0 in. You start on the left. Okay? So I start all the way to the left. That's my tens place value. Does that help us at all? Nope. We go to the ones. Does that help us? Absolutely. I have 4 here. I have 3 there. The rest of this stuff doesn't even matter because I have 4 ones. That's more than 3. Therefore, that is larger. Okay, we're going to skip that one for now. We'll talk more about that one later in the year. It's a little bit more of a difficult question. Okay, let's look at this one here. Which is greater, 1/4 or 3/10? Okay, now a couple ways you could do it. I mean, you could just do 1 divided by 4, but you know there might be times when you don't have a calculator, so let's learn a different way. Okay, now if I know I have the fraction 1/4 and then 0.3, some of you get in the habit of saying 0.3. We got to start saying these the right way. Okay, and the right way would be you always say the last number that you see, which there's only 1, so it's 3, and then whatever place value it is. 3/10. 3/10. So if you said 3/10, think about that as a fraction. 3/10. Okay, now I told you that whenever you're trying to compare fractions, you always have to have a common denominator. So the first thing you could do is just look at them and say, okay, what could 4 and 10 both become together? Or you could find the quick common denominator, which is where you just do 4 times 10, and you know that they can both become 40. Okay, you can do it that way. I'm just going to make them both become 40. Okay, so there we go. I made them 40. Now remember, whatever you do to the denominator, you must do to the numerator as well. Okay, so I know that I multiplied by 10, so I've got to do 1 times 10, which is 10. Okay, here I know that I multiplied by 4, so I got to do 3 times 4, and I get 12. Right away, I have 10 40ths of pizza, and I have 12 40ths of pizza. I know that that is going to be the greater one over here, 12 20ths. So therefore, 3/10 is bigger than 1/4. Here, I have 3/5, and then you could make this into a decimal, that's fine, or read the number. It's not 0.62, it's 62 hundredths. Hundredths. So here we got 62 over 100. Now what denominator could these both become? Okay, well hopefully you're recognizing that this 5 could become 100 by multiplying by 20. You could also make both denominators 500 if you use the QCD. QCD. Okay? So what did we do to go from 5 to 100? Well, we multiplied by 20. So that means we got to do the same to the top. So 3 times 20 is 60. So we have 60 hundredths and we have 62 hundredths. 62 hundredths is bigger than 3/5. Okay? And again, here we are with some more. Well, you know what, let's do 2 more. Okay? Here, 0.2, you got to say it the way it's supposed to be said. That's going to be 2/10. 2/10 and 1/4. What common denominator do they have? Well, you could just do 40 like we did on the previous page, or this time let's do 20, because I know both of those can be multiplied to become 20. So that one would be times 2, so 2 times 2 is 4. 4 times 5 is 20, so 1 times 5 is 5. Therefore, I know that 1/4 is larger. Okay, so 2/10 is less than 1/4. And feel free to continue practicing these. Again, I can check these for you tomorrow if you want to have additional practice. Okay? See you guys.